Hey guys, today we're going to be reminded of how to use trig ratios to solve for sides of a right triangle or angles in a right triangle. You'll remember this as sine, cosine, and tangent. So let's jump right in. Sine gets abbreviated SIN, and sine of x equals opposite over hypotenuse. And you remember this as so, from so, ka, toa. That's how a lot of teachers tell their students to remember it. So sine is the so part. Sine equals opposite over hypotenuse. Let's remind ourselves about cosine, or let's look at a couple examples of sine. So let's say I have a right triangle. Let's say I know that this angle measure is 30 degrees, and I know that this side is length, let's say 3. Okay, so I know that sine equals opposite over hypotenuse. So if I'm at this angle right here, the first thing I need to do is label my sides. Opposite is always across from the angle, so this is going to be opposite. Hypotenuse is always across from the right angle, so this is going to be hypotenuse. And the side that is unlabeled is always going to be adjacent. Okay, so I know that sine is opposite over hypotenuse, which in this case, sine of 30 degrees is going to be opposite, which is 3, over hypotenuse, which is x. So I can do some algebra here and solve for x. The first thing I'm going to do is multiply x by both sides. So that cancels. And then I get x times sine of 30 equals 3. Now I will divide both sides by sine of 30. And that will tell me what x is. So those cancel. So x turns out to be 3 divided by sine of 30. So I'm going to do 3 divided by the sine of 30. And one thing I want to check real quick, make sure that I'm in degrees, and I'm not, I'm in radians. So I'm going to move this over to degrees, and then go back. So I'm going to pull up a second enter to pull that back up, and I get 6. So everything's looking good there. Okay, so x equals 6, so this is worth 6. Now I will show you how I could use, well, let's say this. Okay, let's stick with this example. Since we know that this angle measure is 30 degrees and we know this is a right angle, 30 and 90 make 120 degrees, so that's going to leave me 60 degrees left over for here. So if now I'm standing at this angle, this becomes the opposite. This is still the hypotenuse, and this is going to be adjacent. So notice now I'm working everything in green. So sine of 60 degrees equals opposite, which we don't know, over hypotenuse, which we now know is 6. Now I can multiply both sides by 6. That cancels. So x is going to be whatever 6 times sine of 60 is. So I'm going to go to 6 times sine of 60. And I get 5.20. I'll just round that to 5.20. And there we go. So that's how you can use sine to solve for the sides of a triangle. Notice I basically used the same example for both. So now let's look at cosine. Cosine is abbreviated COS. Cosine is going to be adjacent over hypotenuse. And I'll spell these out. And this is the ka part of so, ka, toa. Okay, so cosine is adjacent over hypotenuse. Let's look at an example. I'm going to take, actually let's work the same example. No reason to switch. So I'm going to start with this. This is 30 degrees. This is going to be 3. So I need to know actually what this is. So I'm going to say this is 5.20. I'm actually going to erase this. The reason being is when I label the sides of my triangle, I need this to be opposite. I need this to be hypotenuse. And I need this to be adjacent. Okay, so cosine of 30 degrees equals adjacent over hypotenuse. So this is similar to the first one I worked. I'm going to multiply both sides by x. It cancels that. So x times cosine of 30 degrees equals 5.20. Now I'm going to divide both sides by cosine of 30. So that cancels. So x turns out to be whatever this is. So I'm going to go to 5.20. 5.20 divided by cosine of 30. And I get 6.00444828. Now, from the previous example, we know this should be 6, so I'm going to say that it's 6. The reason I didn't get 6 exactly in the calculator was because I had rounded this 5.20. If I hadn't rounded that, I would have gotten 6 perfectly. So now that I know the hypotenuse is 6, so again, I know that this angle right here is 60 because all these angles inside have to add to 180. So if I do this now, I switch these basically. This is going to be opposite and this is going to be adjacent. So cosine of 60 degrees equals adjacent over hypotenuse. Multiply both sides by 6. And so x turns out to be whatever 6 times cosine of 60 is. I think I better get 3. So 6 times cosine of 60. And I get 3. So that's good. So x turns out to be 3. So you see that you can use cosine or sine. Really is depending on what you have and what you don't have, the one you should pick. So you definitely need to memorize SO, CA, TOA. Because depending on what I have from opposite or hypotenuse, or if I have adjacent or hypotenuse, or if I have opposite and adjacent, that's what I'm going to pick based on what I have. So tangent is abbreviated TAN. It is opposite over hypotenuse. And it is the TOA part of SO, CA, TOA. Okay, so tangent is opposite over hypotenuse. No, it's not. I'm sorry. Let me erase this. It's not opposite over hypotenuse. It is opposite over adjacent. Apologize for that. It is opposite over adjacent. So let's look at an example. We're going to stick with the same example just for fun. Just so you can see that no matter which one you use, depending on what you have. So if I want to use 30 degrees and I have 3 over here, I'm going to first label my triangle. This is going to be opposite. This is going to be a hypotenuse. And this is going to be adjacent. So tangent of 30 degrees is going to be opposite over adjacent, which I don't know. So this is similar to the first one of the past 2 examples. So times x, those cancel. So x times tan of 30 equals 3. Now I'm going to divide both sides by tangent of 30. Let me erase that, sorry. So x equals whatever 3 divided by tangent of 30 is. So I'll turn to my calculator. 3 divided by tangent of 30. I better get something close to 5.20, and I get 5.19615, so 5.20. So you see that no matter which one of these I use, it gets me the same numbers. So now I know that this is 5.2 basically. Then I cannot use tangent to get me the hypotenuse. If I want to get the hypotenuse, I have to use sine or cosine. So basically tangent is only good for one of the two legs. The hypotenuse you have to use sine or cosine. So there won't be any example 2 here. Let's move forward. That's how you can use sine, cosine, or tangent to find a side length. Now, we can also do the same thing to find measures of angles inside of a triangle, but we're going to use inverse trig ratios. So let me discuss what those are. First, let's make sure that we remember how to set stuff up. So it says find sine of r and cosine of r. So r is my reference angle. So this is going to be opposite. This is going to be hypotenuse, and this is going to be adjacent. So sine of r equals opposite over hypotenuse, so that's 12 over 13. Cosine of r equals adjacent over hypotenuse, so that's 5 over 13. Over here, find sine L and sine J. So for L, this is opposite, and this is hypotenuse, so sine of L equals 30 over 34. And sine of J, I'm going to switch colors for this one, so that makes this opposite, and this hypotenuse. So sine of J equals 16 over 34. Cosine of E and sine of D, so cosine of E, this is going to be opposite, hypotenuse, and adjacent. So cosine of E equals adjacent over hypotenuse. And sine of D, I'm going to switch colors. So that makes this opposite. That's still hypotenuse, and this is now adjacent. So sine of D is going to be opposite over hypotenuse. So sine of D is going to be 4 over 5. Alright, so here I've got the same reference angle both times. I'm using n, so this is going to be opposite, this is going to be hypotenuse, and this is going to be adjacent. So the cosine of n equals adjacent over hypotenuse, and the sine of n equals opposite over hypotenuse. So make sure you can set up these ratios correctly, because it's going to help you solve problems in the future. Let's look at another example. Find the measure of x. So this is a side length. So here's my reference angle. I know that's 56 degrees. That makes this opposite, and this is adjacent because this is the hypotenuse. So since I know opposite and adjacent, I'm going to use tangent. So tangent of 56 equals opposite over adjacent. So I'm going to multiply both sides by 13. So x is whatever 13 times tan to 56 is. So clear all that out. So 13 times tangent of, what was that, 56? And I get 19.27. So x is approximately 19.27. Okay, here it says find the measure of x and y. So here's my reference angle. This is opposite, this is adjacent, and this is hypotenuse. So I can use opposite and hypotenuse, so I can say sine of 32 equals opposite over hypotenuse. Hypotenuse should be 18, so let me change that to an 8 and make that 18. So I'm going to multiply both sides by 18. Cancel that out. So x equals 18 sine 32. So 18 times sine of 32. 9.54. So I'm going to say that x is 9.54. For tangent, I have adjacent hypotenuse, so I can set up cosine of 32 equals adjacent over hypotenuse. So I still multiply both sides by 18. And y is going to turn out to be whatever 18 times cosine of 32 is. So I'm going to do 18 times cosine of 32. And I get 15.26. So y is going to be 15.26. So that's a refresher. Some more examples on how to use sine, cosine, and tangent to find side lengths. I originally this lesson would have taken 2 days in a geometry class, but because we've seen the material before, we ought to be able to handle both directions in the same day. So that's why this is called refresher, but it's not really. So now let's look at how we could actually find the measure of angle A. So it wants us to find the measure of this angle. Okay, how much does that measure? And we can use this 9 and 12. So if this is our reference angle, we need to label this as opposite, hypotenuse, and adjacent. Now you can see I have opposite and adjacent, so I'm going to do tangent of angle A equals opposite over adjacent. And basically I want to cancel out the tangent, so I have to use the inverse tangent. So I'm going to take the inverse tangent of both sides. And that's going to cancel out my tangent. So this tangent inverse cancels out this tangent right here and just leaves me with angle A. Now my calculator, I don't know if you've ever noticed this button, but there is an inverse tangent button. It's right here above tangent. So I'm going to do inverse tangent of 9 over 12. And I get 36.87. So angle A is worth about 36.87 degrees. And I basically just use the inverse tangent. So let's make a note of this. Use inverse trig when you are solving for an angle measure. Okay, when you're solving for an angle measure, not a side length, but an angle measure, that is when you use inverse trig. Okay, inverse trig is going to be inverse sine is abbreviated sine to the -1. Inverse, I should say inverse cosine. Inverse cosine is abbreviated cosine to the -1. And last but not least, inverse tangent is abbreviated tangent to the -1. So let's look at an example of each one. Alright, so inverse sine. So let's say that we have, well, let's do the same triangle we did before, okay? The same one we've been doing all day. So we want to know this right here. We know that this is 3 and this is 6. So if we label this, if this is our reference angle, label this as opposite, hypotenuse, and adjacent, we can see that we have opposite and hypotenuse. Okay, so thinking of so, ka, toa, the only one that uses O and H is sine. So I'm going to say that the sine of the angle equals opposite over hypotenuse. I'm going to take the inverse sine on both sides. So I'm going to switch colors so you can see this. Inverse sine, and then I'm going to do, well, there's not really enough space here. So actually, let me dump that idea. Let me just rewrite it. So sine inverse of sine of the angle equals sine inverse of 3 over 6. So this sine cancels out this one and just leaves me with the angle. So I got to do inverse sine of 3 over 6 in my calculator. So I'm going to do second inverse sine of 3 divided by 6. And I get 30 degrees. And if you go back and look, actually we will go back and look. When I first started this example, you can see that I said it was 30 degrees. So that's why I like to use the same triangle over and over again so that you can see stuff balances out and you kind of have an expectation on what you should be solving for, what you should be getting. So let's go down here and look at cosine. Same triangle. Let's say this is 60 degrees down here. I'm sorry, I don't want the angle measure. That's what I want to solve for. So this is our angle measure down here. We know that this is 3 and this is 6. So I want to know this angle. So here's my reference angle. Okay, so this is opposite. This is opposite. This is hypotenuse. And this is, actually, let me just get rid of that line. Okay. So this is opposite. This is adjacent, and this is hypotenuse. So the only one that uses adjacent and hypotenuse is cosine, which is CAH, C-A-H. So I can say that the cosine of my angle equals adjacent over hypotenuse. So I'm going to take the inverse cosine of both sides. And this cosine cancels this one out. So I'm just left with the angle. Now I've got to do inverse cosine of 3 over 6. And if you remember the triangle from the beginning correctly, we better get 60 out of this. And I get 60. That's exactly what I expected to get. Okay. So that's how we use inverse sine and inverse cosine. Now let's look how to use inverse tangent. So let's say I've got the same triangle. I'm going to say that this is 60 degrees. Nope, I'm not. I'm going to say that this is my reference angle. This is going to be 3. This is going to be 5.2. And I'm looking for this right here. So since this is my reference angle, that's going to make this opposite, adjacent, and hypotenuse. And the only one that uses opposite and adjacent is tangent. So the tangent of my angle is going to be opposite over adjacent. And if you remember correctly, this better be 60 degrees, but since we rounded this, we're going to get close to 60. So don't expect perfect 60 when we get there. So I'll take the inverse tangent of both sides. This tangent cancels this one out. And so my angle is going to be inverse tangent of 5.2 divided by 3. So I'm going to say inverse tangent of 5.2 divided by 3. And I get 60.01836. So I get 60 degrees, which is exactly what I was expecting. And I know I can say that's 60 because I know I rounded this number here for the 5.2, so I know this isn't going to be perfect, but I expect it to be 60. So that's a refresher on how you use sine, cosine, and tangent to solve for sides and to solve for angle measures. I hope that helps, and then there's some practice work that I want you to try.